have your test graded, not completely, mostly by Monday. I've lost what I wanted to do here. I was going to show you when the next test would be. So if you scroll through on our calendar that's on the home page in Canvas, you can see that we're reviewing next Friday for our Unit 3 test. We'll review Tuesday, and then we'll test on that, review on Monday, and then test on the Tuesday. So next week, we'll finish Unit 3, start reviewing, and we'll test the week after. We are going to go ahead and get started on our notes today. 3.5, linear equation. So we are reviewing linear equations because many business situations are modeled by a linear equation. Typically, if we change an input in a business or financial situation, then our output is going to change by a consistent amount, right? If we're thinking about how much it costs to create an item or to manufacture an item versus the amount of profit we make, if that item costs less than 8, our profit's going to go up by a certain amount or a certain percentage. If that if the cost goes up, then our profit should decrease consistently, maybe not by that exact amount, but a consistent percentage. If our costs go down, then your profit should go up. The inputs affect our outputs. And while in a real world situation, they may not be exactly linear, so we're going to give a slope or a rate of change as -18. In the real world, it might be somewhere between -17.5 and 8.2 or something like that, but we can represent them basically as a linear model. We can see they go up and by about the same amount or the same rate when the x's change, the y's either increase or decrease by the same amount, and so that's why we're reviewing them. Some of the things that you need to remember is that what does the slope and the y-intercept represent in a linear equation written in slope-intercept form. So in a linear equation, the x and the y, remember, are always there in slope-intercept form, but we'll have a numerical value for the slope, a numerical value for the b or the y-intercept. So we're going to talk a little bit about those. The m represents, in a real-world situation, a more appropriate term for that would be the rate of change. The slope, the change in y over the change in x, but if we want to refer to it, we would call it the rate of change. This is the formula. M stands for slope or rate of change. So this y2 minus y1 divided by x2 minus x1, you can always use that. So this formula here, the change in y divided by the change in x, when we find the difference of two numbers, that's the change, right? Difference of change is the same thing. We are going to be writing ours mostly from a table today. You could use this formula from the table information as well, but ours are pretty simple ones today. The b is the initial value or the beginning value. I was going to give an example of how it's not the same as like your initials of your name, but then I realized it's exactly like the initials. My initials are PZ because the first letter in my first name is P, the first letter in my last name is Z. I'm pretty sure that's why they call them initials. It's the initial letter in your name, first and last. So that initial value is the beginning value. When you talk about your initials of your name, it's that beginning letter in each of your names. So the initial value is the beginning value. Remember, I didn't write it because I didn't put my board on, but here, y2 minus y1 divided by x2 minus x1, this change in y, change in x, all refers to an x and y coordinate in an ordered pair. So if a situation is modeled as a linear equation, it could also be graphed in a coordinate plane. Any points in a coordinate plane would have an ordered pair to represent their location on that coordinate plane. Zeroth term, that just means when x is 0, it's the y term. B stands for y-intercept, it represents the y-intercept, and that is the y value when x is 0. So these all mean the same thing, they're all referring to the same value. If we've got a coordinate plane, the y-intercept is where that linear equation would cross the y-axis, right? So we should remember the just in case we don't, where we're getting at a little bit. So for these examples, we're literally can complete these examples just by filling in the blanks. That's what we're going to write at the top here. So for these, we can fill in the blanks. And what I mean by that, you can see I have blanks down here. This blank, you fill it in with the slope or the rate of change. This blank, you put it in with the b or the y-intercept, the initial value. So for example 1, what will we put next to the x here? 7, the slope, so this is our slope. The initial value, that's our b. This equation could represent the cost of making an item. Starts at the set cost of $38, no matter how many we make. If we make 1, it's 7 times 1 plus 38. If we make 10, it's 7 times 10 plus 38. So these linear equations model situations in science, math, all kinds of things, but it shows you how your output, remember y is your output, your x is your input. How does your output change when we plug in a different value for x? Example 2, slope and initial value. So slope and y-intercept. Fill in the blank. You can have a negative slope, or slope can be a fraction. Because I can't see. What is it, 15? So you'll be happy to know one of the things I did after yesterday was I went and got glasses. Oh, what are glasses? Hopefully they'll be in here. All right, negative 15. Thank you. Slope, rate of change. So this is the slope. Remember, that's also the rate of change. Slope and rate of change are the same thing. I sometimes will abbreviate that, ROC. Doesn't matter, the slope can be a fraction. So in the blank for slope, 2/3. In the blank for the beginning value or the y-intercept, -6. But that's not how we're going to write that equation, right? If c is negative, we're going to rewrite that as a fraction. I'm sorry, as a subtraction problem. So we would rewrite that equation as y equals 2/3 times x minus 6. What would the equation, for example, 4 be? What do you think, Kennedy? Yes, y equals negative 5x. Why didn't Kennedy put the 0 there? So if you plug it in to fill in the blank, we would plug it in there, but then we have to realize we're not going to leave +0 in an equation that we're going to use. So remember, we're using this to input different x values. What is the point of having that plus 0 there? It doesn't change anything, right? So we would simplify that to just y equals negative 5x. So far, so good? So the x and the y are always an x and a y. The numerical values are the rate of change and the initial value or the y-intercept. So we did write the formula for slope or rate of change. So really, if we have a table, sometimes we can just look at the table and see how the x's or how the y's are changing when the x's change. So if our inputs are changing just by 1 each time, so at 1 month, so this is a real world situation. So after 1 month, their balance is 120. After 2 months, their balance is 105. What happened to their balance? It decreased. How much did it decrease by? It decreased by $15. So we would say to get from 120 to 105, that was a negative 15, right? Now, they told us this is a linear equation, so they've implied that this table represents that linear equation. We could use these 2 points and plug in the slope formula, but if for every month it goes up, the balance decreases by negative 15, that is our rate of change. So that's our rate of change, which remember is our slope. So it goes down by, remember the rate of change is the change in y over the change in x's. So negative 15 over 1, because it went up by 1, gives us a rate of change of negative 15. Does that make sense? Since rotary exposure is Chromebooks for now, thank you. So can we figure out what our initial value is? What is our initial value going to be? What is the balance going to be after 0 months? Well, we have to know, we wrote that in our notes at the beginning. So your y-intercept, your initial value, is the y value when x is 0. In this real world problem, this means if x is 0, that means that's the beginning, right? That's the very first day that we're talking about. So here, how do we figure out what that balance is? That balance is at 0. Well, from here, from 120 to 105, we went down 15. What if we reverse it? We're going to say 105, how did we get to 120? Plus 15. So what would the beginning balance be? Yeah, 120 plus 15. So the beginning balance is 135. That is our initial value. That is our V. And if we're writing the equation to model the information given in the table, then remember this is what gets plugged in for the slope. This is what gets plugged in for the V. So that's M and V here. Now that's just not part of the equation, so I'm going to stop writing that, but I'm just reminding you that's what this represents. So that would be the linear equation to represent the information in this table. What's it going to be after 3 months? What's the balance going to be after 3 months? Sincere, do you know how to find that? 90. 105 minus 15 is 90. Okay, so it is important when you are looking at a table to see how the x's are changing. So here the x's went up by 1. Here the y's went all down by 15. The change in x's and y's have to be consistent, but they don't have to be the same. So these, if you're just from the table, picking that change in y and change in x, you have to think about that, then the comparison of the two or the division of the two. So in this example 5, the number of weeks is going up by 2. They only give us data for every 2 weeks, right? So from 2 to 4 is a a change in input of what? Plus 2, right? What is the change in the y's for those same 2 weeks? Negative 7, right? Now, our slope, or rate of change, is not negative 7. It's the change in y compared to the change in x's, and we can write that as just a fraction, negative 7 over 2. So that is our rate of change, which is our slope. You could also write it as negative 3.5, which usually in a real-world problem we will convert them to decimals. Most people use a decimal versus fraction, unless you're baking more fractions or cooking, not so many other times. What? Nothing? Okay. I forgot I wanted to give you one of these topics. Okay. Just later. Okay. All right. So what is the initial value? So how can I figure out the y? What do you think, Kalani? What's the y going to be when x is 0? So negative 19 minus 7 gave me negative 26. If I go from negative 26 up, I'm adding 7. So it's add 7 again. You guys know which there was? It's negative 12. That makes sense, Kalani? What is, can you tell me what it would be symmetrical? Okay, so let's do it again. So from going down, we're subtracting, and that's how we would look at the rate of change. But if we just want to find a missing value, we just go back up and do the opposite, right? So from here to here is down 7, from here to here it will be up 7, right? So if we go up 7, 1 plus 7 will give us negative 26. Very good, negative 33. We can go ahead and plug in our initial value in that length. And we could go ahead and plug in our rate of change in the slope length. Plug in the beginning value there. So let's do that. We're going to put in the decimal and negative 12. But we would not read it plus a negative. We would rewrite that as negative 3.5 times x minus 12. Probably decimal, I can't remember, but we should take it either way. That'd be one of those things that you put it in as a fraction, and it didn't take it when that's what I'm doing. Most of the test is auto-graded. I'm just going to go back and give you more credit. So the two things I'm going to do when I grade the test this weekend, if I gave you extended time, I do need work. If you took advantage of the extra 20 minutes, I need work for all those problems. It's come to my attention. I think the answers were already posted, and that's fine. I'm not going to be too weird about that as long as you have work to show that. And the other thing I'm looking at is that sort of thing. So if you put in 1/2 and the correct answer you put in 0.5, I would want to give you credit for that, right? If you have a rounding error, then you would get the whole thing wrong, but I would go in and give you most of the points. I would just take off half a point or something for that. So that's the kind of stuff. So, except for the people that the 20 minutes, that took advantage of the extra 20 minutes, no one's grade should go down, it should only go up. If you did take advantage of the extra 20 minutes and you got some right, but you don't have work for it, then you're not going to get those points. Okay? Make sense? Okay. And we only have one more sample, so we should be able to start on our finishing our 3.4 activity from yesterday. We're starting our amplify. Here we go. Oh, that's good. Awesome, that's good. Can everybody see that pretty well? Me either. All right. I wanted it a little bit bigger than that, but I think it's too big. too big. Okay. So this is a word from a real world situation. We do see that we have a table that represents, we can see that our X represents the number of months, our Y represents our balance, and our last column we just assume it's a checking and savings account balance or some sort of balance, right? It could be, well, we owe somebody or don't, we didn't know. But here, we've got a little background information. We know that this table represents Marco's checking account. It tells us he has a minimum balance requirement of about $1,500, and if he goes below that amount, they charge him an $18 fee each month. The count is below that minimum. After buying school supplies, Malcolm's balance is $1,482. So he is below that minimum balance, right? If he's below that minimum balance, that he is going to have, they're going to subtract $18 from his account each month. So, what is his balance going to be at 0 months? So, that is his starting balance, $1,482, and that's going to go in as his initial value. That is the beginning balance right there. Table. So it does say that he's not going to make any more deposits or withdrawals. So we've identified the initial value. Now we're going to identify the slope. We already know the slope here. So you can come in with the slope here. Is the slope positive 18? So if it's not positive 18, remember when we're talking about money, if it goes up, if it goes up by $18, that change would be positive 18. But if it goes down by $18, it's what makes it negative 18. So the slope is negative 18. That's how the y's change when the x's change. So after 1 month, if you have 1480 to start with, his balance after 1 month is 1464. After 2 months, we could subtract another $18, and it's $1,446. Pretty easy, 3 months, subtract another $18. What if we wanted to know how much money he had after 18 months? Do we want to have to write a table and keep subtracting 18 every time? We do not, and that is the value of creating an equation that represents this situation. So we can create our equation. We already know the slope, which remember is our rate of change in this real world problem. And that is negative 18. And his beginning balance is his y-intercept or his initial value. So now, if we want to know after 18 months what is his balance, we can rewrite we could just plug in for x, but we could also put it in function form. Madeline, you're awake, right? Okay. We could put it in function form, and we worked with functions already, so we could say remember, y and f of x are the same thing. If we say f of 18, that means we're plugging in 18 for our x value. So we can plug that in on our calculator, and then we know that when x is 18, y is $1,158. So the last thing is sometimes one of the hardest things for kids. Kids can do the math, sometimes applying what does it mean in this real world situation. So what is the meaning of x equals 18 here? When we say x equals 18, when x equals 18, y equals 1158, what does that represent? Anybody have an idea? What do you think? Sincere? Sorry? I can't hear you. Nathan? Yes, that's exactly right. So we should know if that when we say x X equals 18, Y equals 1158. That is after 18 months, Marco's balance will be $1,158. So what does it mean X equals 0? Well, that is his beginning balance. That's Marco's beginning balance. What does it mean when we say when X is 2, Y is 1,446? That means that's his balance after 2 months. So that could actually be a question on your test. You should know what it means, what those ordered pairs represent. So X and Y, those also could be written as ordered pairs. And that's all I have. You can scan and submit. So then I'm going to open your test. You want to come get your notes, Savannah?